In today's video, we're going to talk about how to find the volume of cylinders and prisms. So for the last few weeks, we have been talking about surface area of these solids, these 3D figures. So the difference between what we've been doing previously and what we're about to do is this. Surface area involves if you were going to paint the outside of a solid, how much paint would be required to paint the outside. When we talk about volume, we're talking about how much stuff I could fit on the inside. So how much stuff can I fill the inside of the solid with? So for volume, a lot of students usually find this a lot easier than surface area, just for the fact that the volume formula is a lot simpler than surface area. In order to find the volume of any prism, any two-based figure, or a cylinder, two-based figure, it's just area of the base times the height of the figure. So remember from surface area, we had to worry about finding the perimeter of the base to use the formula. To find volume, we don't need the perimeter of the base at all. So all we have to worry about is big B, area of base, and then height, distance between the bases. So in this rectangular prism, we have a rectangular base. It has dimensions of 3 by 5. So all we're going to do is multiply 3 by 5, and we get an area of base of 15. The height of the figure is the distance between the bases. So in this case, base is on top and bottom. So my height is 8. To find the volume of that prism, all I have to do is multiply the big B and the H. So multiplying big B and H is going to give me an answer of 120. Now, when we were talking about surface area, we were using units squared. So inches squared, meters squared, feet squared, and so on. When we talk about volume, how much fits on the inside, this is where we switch gears and we start talking about units cubed. So in this case, my final answer, 120 inches cubed. Moving down to number 2, again, it's a two-based figure because it has triangular bases. So this is a triangular prism. So triangle here on the front would be considered my base. Important thing to remember about a triangle's formula for area is it's 1/2 base times height. Many forget the 1/2 and then they end up with the wrong area of base. Please remember that the area formula for a triangle is 1/2 base times height. Looking at my triangle, it has a height of 3 and a base of 4. So plugging those in gives me an area of base of 6. Height of the figure is the distance between the triangular bases. In this case, it's 2. And my volume is simply just base times height. I get a final volume of 12 cubic meters. Very simple. The one on the bottom is a cylinder. Again, a two-based figure. So finding the area of the base is pi times radius squared. In this problem, you'll notice that you're given the diameter. So halfway across the base is 6. So that's what goes in for the radius. If I do pi times radius squared, we end up with an area of 113.1. The height of the cylinder is the distance between the circular bases. So in this case, 10 feet. And then finding the area, or the volume of the cylinder is just area of base multiplied by the height of the prism. So, of the cylinder. So 113.1 multiplied by 10 is just going to give me a volume of 1131. And then my units will be in cubic feet, so feet cubed. On the back of your sheet, we have two different regular polygon-based figures. So the first one has a base shape of a hexagon. So finding the area of the base is a little complicated. So remember, we're going to draw in a triangle. And what we learned was the bottom side of that triangle is halfway across the edge length. I have to figure out the height of the triangle. And we have to figure out what that angle is in there so that we can use some trig. So 360 degrees split by 12 triangles, double the number of sides, gives me 30 degrees for that angle up there. So I'm going to redraw that triangle so you can see it a little better. This is what it looks like. X, 3, and 30 degrees. So if I want to figure out the value of x, I'm just going to use tangent. So tan of 30 equals 3 over x. In order to figure out, you're going to do division, and I end up with an x value of 5.2. So what I need to do then is find the area of this little triangle. That area is found by doing 1/2 times base times height. Doing that calculation gives me an area of 7.8. That is only the area of this little triangle. So if I want the area of the entire base, I have to multiply by the number of triangles. So 7.8 is one of them, and there are 12 triangles that I can make around that hexagon. So I end up with an area of 93.6. The height of this prism is the distance between the hexagon bases, which is just 8, and my volume is just base times height. So once I've found that my area of base is 93.6, if I multiply by the height of the prism, which is 8, I get final answer of 748.8, and it would be in cubic meters, so meters cubed. So finding the area of the base in this hexagon-based figure is a little more difficult than finding the area of the base of the figures on the front. Doesn't mean you can't do it, it just means that it's a little bit more time-consuming, a little bit more labor-intensive. The last problem is similar, except that the shape of the base in this case is a pentagon instead of a hexagon. So first thing we're going to do is find the area of base by first drawing a little triangle inside and figuring out that this bottom side is halfway across the edge length, so 3.5. I need to find the height of the triangle, and I need to figure out what that angle measure is. 360 degrees, divide by double the number of sides, because that's how many triangles you can make, makes that angle inside 36 degrees. So again, I'm going to redraw that triangle down here so you can see it a little better. We said the bottom was 3.5, that was x, and we said this angle was 36 degrees. Figuring out what the area of this triangle is going to involve the exact steps that we did above. First, we have to find the height by using the tangent ratio, opposite over adjacent. So anytime I have a trig ratio set up this way, we're going to use division to solve. So if I divide, I'm going to end up with an x value of 4.8. In order to find the area of this little triangle, we do 1/2 base times height. Oops. So base of 3.5, height of 4.8. Remember, the formula for a triangle has the half in there. Don't forget the 1/2. So if I multiply those, I'm going to end up with an area of that little triangle of 8.4. Now, things to keep in mind. That 8.4 is only this little triangular piece. So in order to find the area of the entire pentagon, I have to take the area of that little triangle, and I have to multiply by the number of triangles I can make, which in this case is 10. So area of base is area of that one little triangle, multiplied by 10 this time. So I get a big B of 84. And then the height of the prism, distance between the pentagon bases, is also 10. To find the overall volume, all I have to do is multiply big B by H, and I get a volume of 840 inches cubed. Like I said, most students usually find volume a lot easier than surface area because it requires less work and the formula is more simplistic. So we're still finding the area of the base just like we would with surface area. We're still identifying the height of the prism just like surface area. But those are the only two numbers you need. We don't need the perimeter of the base like we did for surface area. Make note of any of the problems that you need more explanation on, and you can ask about them in class.